In this beautiful question on bearing and distance, we are given that two cyclists X and Y leave town Q at the same time. Then cyclist S travels at the rate of 5 km per hour on a bearing of 049 degrees, and cyclist Y travels at the rate of 9 km per hour on a bearing of 319 degrees. First, we are to illustrate the information on a diagram. Then, after traveling for 2 hours, we are to calculate to the nearest whole number the distance between cyclist X and Y, and then the bearing of cyclist X from Y, and finally we are to find the average speed at which cyclist S will get to Y in 4 hours. So yeah, our first mandate is to illustrate the information on a diagram. And looking at the question, we are told that they leave town Q at the same time. So Q will happen to be our point of reference. So if we are to locate point Q and we draw our 4 cardinal points, this is a 4 cardinal point from where we are going to take our bearing from. And in the first case, we are told that the cyclist S travels at a rate of 5 km per hour on a bearing of 049 degrees, and cyclist Y travels at the rate of 9 km per hour on a bearing of 319 degrees. So to locate the bearing of cyclist S, which is 049 degrees, if we take this as the north, the south, the east, and the west, and we are trying to locate the bearing of 049 degrees, that is going to be between north and this, because normally we start taking bearing from the north and we go in the clockwise direction like this. But here we are told it's 049, meaning that it's not yet a right angle. Between north and east is a right angle, which is 90. So 49 will be here in this particular first quadrant. So we can just take our bearing that will go from north, and this is 049. Okay, so we can just take that bearing to now go somewhere like this. So this is where the cyclist X will be. Okay, so that's the first thing we need to do. Then for the cyclist Y, we're told that he is traveling on a bearing of 319 degrees. So how do we get 319 degrees? From the north to east, that is 90. From the north to the south, you can see it's a straight line, that is 180. From the north to the west, that's that 180 plus another 90, making 270. So from north to west is 270, and from north, making a complete circle, is 360 degrees, because that will now amount to the angle at a point. But here we are being told it is 319, so that will be in this last quadrant between 270 and 360. So you can just say we are moving somewhere like this, and this will be 319 degrees. So you can also take that bearing just straight up to where cyclist Y will be located. So I think this is a good representation of what we have as that bearing. So if you want to label, we can say this is point Q, okay, then this is point X, and this is point Y. Something of interest that I would like us to note, I took this to be longer than X because look at the information that we are given. We are told that the cyclist X travels at the rate of 5 km per hour. So that is 5 km per hour. This is for the X. But the cyclist Y travels at the rate of 9 km per hour, and this is Y. Now look at 9 km per hour and 5 km per hour. Of course, definitely the one running on 9 km per hour would have covered more ground, more than the one running 5 km per hour. In short, I think my 5 km per hour is way too long, because 9 is almost twice the size for the X, so I should have it somewhere here. Okay, and that is where you paying attention to the details that was given will really help to solve the question that you are trying to solve. So I can say this is my X, because Y would have traveled almost twice the length of X with the information that we are given. And Why am I doing this? Is because you are going to get your diagram more correctly and you'll be able to solve the question better and easier, okay? You won't have a drawing that will be negating what you are trying to postulate as the thing to get from the drawing. So good and beautiful like this. This is the information that we're asked to illustrate on a diagram, and it's like this. Now I want to just put some little effects. I want to bring in my cyclist, so let's just wait for that. So I love the fact that I brought in my cyclist to reflect on my diagram, just like we used to have on our textbooks. So then you don't need to show this. I just using this so that I can have a pictorial view of what I'm trying to talk about. You can see I'm reflecting that the person traveling at 9 kilometers per hour is traveling faster than the person moving at 5 kilometers per hour. And just to complete the triangle that we are drawing, you can use a straight line to join X to Y, just like this. And then we are good to go. I love this. So with this, we have the information illustrated in the diagram as requested, and then we can move on with the other questions. So now, after looking at the first question, we are being told here that after traveling for 2 hours, we are to calculate to the nearest whole number the distance between cyclist X and Y and the bearing of cyclist X from Y. Let's take it piecewise. To get the distance between the cyclists, look at all the information we are given. We are given the speed, and now we are being given the time to be 2 hours. Now, by reason of understanding of speed, distance, and time, we know that speed is defined as distance over time. Speed is distance over time. But normally, working with bearing and distance, even look at the word that we use. We say bearing and distances. So here we need to find the formula for the distance. And distance, in this case, is equal to the speed multiplied by the time. Okay? So this is what we ensure that we are working with the right values, because given the speed, we need to get the distances that we work with so that we can even find the distance between cyclist X and Y. So for the cyclist X, after 2 hours, we can say after 2 hours, the distance covered by cyclist X, the distance covered by cyclist will be his speed multiplied by the time, and the speed we are given already as 5 kilometers per hour multiplied by the time, which is 2 hours. Now 5 times 2 is 10, but here we have kilometer per hour multiplied by hour. Now per hour means divided by hour, then multiplied by hour. You can see the hours will cut out and we have only the kilometer left. So that is actually the distance covered by cyclist X. And in the same vein, the distance covered by the cyclist Y will be, what's the speed for Y? It is 9 kilometers per hour multiplied by, they are using the same time, so we multiply by 2 hours, and that will be 9 times 2, that will be 18 kilometers. We now understand how to knock out the hours from the unit. So if you go back to our diagram, that is just telling us that the distance from Q to Y, that's the distance of the cyclist Y, is 18 kilometers. So here we have 18 kilometers, okay? And the distance from Q to X, distance of X is 10 kilometers. So we have here is 10 kilometers. But look at the question that we're being asked. First and foremost, we are to find the distance between cyclist X and Y. This is the line XY, which is facing Q. So here is what we are told to look for that we don't know. And for us to evaluate this, let's look at the diagram holistically, okay? If you are looking at this diagram holistically, look at this particular point. Here we're having a triangle and we don't even know any of the included angles. So starting from Q, where we are taking our bearing, let's see if we can find this angle so that we can use any of the mathematical rules that we have at our disposal to solve for this length XY, which will correspond to the distance between cyclist X and Y. So here at point Q, originally we have this bearing of X from Q to be 49, and then we have the bearing of Y from Q to be 319, but we can say we want to look for this particular point, this angle. And how do we find that? Look at it. From north to north is the angle at a point, and that is 360 degrees. And from that 360 degrees, we have already taken 319 out. So this particular place will be 360, which is angle at a point, minus 319. So we can say that will be 360 degrees minus 319 degrees. Okay, so 360 minus 319, you can say we borrow 1 from this 6 remaining 5. 10 minus 9, that is 1. Then 5 minus 1, that is 4. So we have this as 41 degrees. So we can just go to that point at Q and say this is now 41 degrees. Right. This is very good. That's very interesting. So 41 and 49. What's 41 plus 49? 41 and 49. 1 plus 9 is 10, remaining 1. 4 plus 4 is 8, plus that 9 is 90. This is quite interesting now. So we can say the angle here at N is actually nothing but a right angle. A right angle here. This is angle 90. And if you can define this as angle 90, that means, yeah, we are working with nothing but a right angle triangle. Right angled triangle. I love this type of questions because our understanding of how to interpret the question is going to give us quite a whole lot of solution that we need. For a right angle triangle, we know that Pythagoras theorem, I love this. Pythagoras theorem can be used to solve for the side that we are looking for. And what is that telling us? It's telling us that the square of the hypotenuse is equal to the square of the adjacent plus the square of the opposite. And the longest side, or the side facing the right angle, is the hypotenuse. So here, if you want to actually represent this well, the side facing Q will be small q. So this is small q. The side facing x will be small x. So this is small x. And the side facing y will be small y. So this is small y. So from here, we can just see that this implies that q raised to power 2 is equal to x raised to power 2 plus y raised to power 2. And x we found to be 18 kilometers, y is 10 kilometers, and we're looking for q. So we can say the square of q is equal to s square will be 18 raised to power 2 plus y square will be 10 raised to power 2. And if we want to bring in our calculator to solve that, you can just say 18 raised to power 2 is what? That's 324. So this is 324 plus 10 raised to power 2 is 100. So 324 plus 100 is 424, such that q, this is q raised to power 2. So q itself will be the square root of 424. Okay, so how do you find the square root of 424? We go to our calculator and press square root of 424 is equal to what? This is 2 root 106. But I want to express it in decimal place. So this is 20.5913. So this is 20.5193. But look at the question. We're told to calculate to the nearest whole number. So we need to approximate this to a nearest whole number, meaning that we don't want any decimal place there. And for us to do that, we need to look at the number immediately following the decimal place, and that is 5. So numbers between 5 to 9 will round up to 1 and add to the initial number before it. Numbers between 0 and 4 will round down to 0 and it will not have any effect. But here it is 5. So when we round 5 up, it will become 1 and we add to 20. That will be 21 and the unit is kilometers. So 21 kilometers is the distance between cyclists X and Y. And we can just reflect on our diagram that this is here that we tag as unknown. We have now gotten it to be what? 21 kilometers. I love this question. Okay. So now we've gotten the distance between cyclists X and Y to be 21 kilometers, approximately 21 kilometers. Now we have to find the bearing of cyclist X from Y. From Y means that we need to go to Y to consider taking our cardinal point from there and look at the bearing of X from Y. So So we can go to Y to take our bearing, okay, just the 4 cardinal points that we'll be needing. All right, so here we can just identify these to be the north, the south, the east, and the west. Okay, so the bearing of X from Y, we need to start from the north and look at it to the inclination of X to Y. So if you are looking intently, we can see that that is identified as this particular place here from the north to this angle. Okay, this is the bearing of X from Y. That particular angle, let me just call it theta. Okay, then looking at this, because if you're identifying that as theta, we need to now look at how do we get that angle theta. From what we have done before, we got this angle at Q to be 41, but we can observe that this is going to be alternate to this angle at Y, but to the south of it. I can show that with the aid of a diagram, that if you take this particular angle here and you run it down to Y, okay, and then you come down south, this new angle here, this angle here, and this angle that we got initially as 41, they are alternate angles. So this will also be 41 degrees because alternate angles, they are equal. So that is 41 degrees, just like this is also 41 degrees. So if you have been able to find that to be 41 degrees, you can find a suitable means to evaluate this angle theta, because you know that angle on the straight line north to south, that's a straight line. The sum of angles on that straight line is going to be 180. Now we have 41 here. If you can find this angle at Y, okay, this angle at Y, this one in red, which is the angle corresponding to Y, okay, at that particular point of this triangle, then we can use that to sum 41 and this angle and theta, and we can equate it to 180 degrees in such a way that we can now find the value for theta. We can just say that at location Y, theta plus the angle XYQ, that's the angle at Y here, okay, plus 41 degrees that we have gotten to be alternate to this 41 from Q. The addition of the 3 is equal to 180 degrees. Why? Because they are the sum of angles on a straight line. So sum of angles on a straight line, they add up to 180 degrees, and we are leveraging on our understanding of that. So we already know 41 degrees. How do we find angle SYQ? Look at this triangle. Okay, look at this triangle. We already know the hypotenuse. We know the opposite to this angle. Opposite to this angle is 10 kilometers, which is small y. Then we also know the adjacent, which is 18 kilometers. But we are looking for this angle. So what do we want to make use of that will help us? We can make use of any of SOHCAHTOA. Okay, SOHCAHTOA is a trigonometry identity that we can use for a right angle triangle like this, in which we are looking for a particular angle while we know all the sides and we also know the right angle included. So yeah, let's say we want to use either opposite and adjacent or anyone, but we want to relate it to this particular angle. We can say, which one do we use? We can say we want to use tan. We can say from there, tan XYQ, which is ideally opposite over adjacent, because from here, SOHCAHTOA, tan is opposite over adjacent. This is the same thing as what's the opposite? The opposite is 10 and the adjacent is 18. Students, as a rule of thumb, it's even good that we use tan, because the value that we got for the hypotenuse, you can remember, it was an approximated value. So here we have approximated it. It was actually 20.59126 or so. But we are using absolute values that were given in the question here. So our approximation can be on the right track, because at the end of the day we are still going to find our answer to the nearest whole number. So we don't need to complicate issues for ourselves. Let's just use the values that we are given. So tan is ideal for us. So that means that tan xyq is equal to 10 over 18. What is 10 over 18 from our calculator? 10 divided by 18 is what? It's 5 over 9, which is 0.5. This mark on top of the 5 means that it is a repeated value. So I can say it is 0.5555, then 6, since I will approximate that, such that angle xyq is equal to arctan, I could even have said arctan 10 over 18 straight. Okay, so arctan 10 over 18, what's that? I can say arctan, the answer I just got, that's 29.054, or I could have said directly it is arctan 10 over 18. So what's this? 29.0546. That's 29.0546. Good. But this is where we're actually going. We want to make use of that in this equation, such that we are going to have, therefore, our theta that we are looking for is going to be 180 minus the sum of this SYQ and 41, and XYQ we have gotten to be 29.0546 plus 41. Okay, when these two, when they move to the other side, they will become minus. So we can subtract them from 180 to find the value of theta, which is the bearing of cyclist X from Y. Alright, so if we bring in our calculator, we can say this is 29.0546, okay, plus 41, that is equal to what? So now I can say 180 minus the answer I just got. So this is 109.9454. 109.9454. This is 109.9454. But look at the question. They told us to get it to the nearest whole number. So we need to approximate this. So, and in short, bearings are always expressed only in 3 digits. You don't put decimal place in bearings. So that means we need to knock out this particular 9. And if we take 9, we are going to round it up to 1 and add that 1 to the initial number before it, and that is 9 here. That 9 plus 1 is 10. So what we are going to have is 110. Okay, so this is approximately equal to 110 degrees. So the bearing of cyclist X from Y, here our theta is nothing but 110 degrees. All right. So here in our final question, we are asked to find the average speed at which cyclist X will get to Y in 4 hours. So when X got to here and Y is here, Y will be stationary, and then X wants to move from this particular point to Y at this point. So we have to find the speed which it needs to travel at to get to Y, but in 4 hours. If you recall, initially we said our speed is nothing but what? Is distance over time. So that's one of the things that we did immediately we are starting with this particular question. But here we are told that we have to find the speed of X to Y, okay, in 4 hours. So that time we have been given to be 4 hours. But what is the distance that we need to look at? Look at what we have here. We have 21 kilometers, but recall that this is an approximated value. Whenever you are walking, don't use approximated value to solve further questions. Use the original value. Then when you get the final answer, you can approximate. But even look at this question. They didn't ask us to approximate. They just said find the average speed. So what was the original value we got for Q the other time? It was, I think, 20.591. Yes, 20.59126 kilometers. But now, what's the time that we are looking at? We are looking at this time that is given is now 4 hours. So the speed that X will need to take to get to Y will be this 20.59126 divided by 4. So we can bring in our calculator to say we have 20.59126 126 divided by 4, and that is what? 5.1478. 5.1478, but now it will be kilometer per hour. This is quite long. We can just take some little approximation to take this is nothing but 5.15 kilometers per hour, because if we take 7, we will round it up to 1 and add that 1 to 4 to make 5. So the average speed at which cyclist X, this guy, will get to Y, this guy, when he's there in 4 hours is nothing but 5.15 kilometers. So you have seen how we can actually solve questions on bearing and distances, how we can interpret the question as we are given, how we can use our understanding of triangles, the rules that pertain. Sometimes we get to use sine and cosine rule, but here we get to use the Pythagoras theorem and trigonometry identity, SOHCAHTOA, and we've been able to solve this question, albeit we use our understanding of the fact that speed is distance over time. So we first converted to distance to get the distances in bearing and distance, and then later we're also working with the speed again. And the more you practice with this type of question, the better you are going to be. You can check our playlist. We have quite a number of questions on bearing and distances, angle of elevation and depression, triangles in general, and you can make use of them to build your proficiency in this type of questions. All right.